210. Hello, good afternoon. Welcome to a new food4Rhino webinar. Today it's about point clouds for Rhino. This is a plugin by Veesus company in the UK, and we have the pleasure to have Mark Score with us. He's the managing director of the company, and he has extensively experience in managing, in working with LiDAR scanners. He founded the company already some years ago, but before he was working in the military, and he has experience in engineering, business development, and in leading teams and projects. And this plugin is available both for Rhino and SolidWorks. He will mention that as well. And I think he will also talk about our new app he has developed, it's Zapcha, that allows to view your large sets of scan data also on a mobile device. Remember that this webinar is being recorded, so if you want to watch it later, at this same link, it will be available right after it finishes. And also there is a chat on the right part of your screen. Feel free to use it. Feel free to place any questions there. I will pick them, and then at the end of the session, we will ask Mark in case he didn't cover anything of your interest. So Mark, many thanks for being with us today. And if you want, you can start now.
Thank you very much. Yeah, welcome, and thank you for taking the time to join us today on the webinar. It's greatly appreciated. And thank you to McNeel Europe for hosting this webinar. What I'll do is I will share my screen so you can see the presentation that I'm going to be giving. It'll be a very brief presentation, really to take you through where we are and where we've come from a Veesus point of view. And then I will dive straight into showing you the software itself, where we have my colleague Matt Ransom, who's using the controls, and I'll be doing the voiceover for Matt. So I'll be prompting what he's doing, so you get a good feel for what the plugin does. Okay, so this is the first slide, and almost the only slide. Who are we, Veesus, as a company? As Carlos already said, we all of us in the company, bar one, has a defense background. And we were introduced to point cloud data some 20 years ago now. So really in the very start of the point cloud revolution, if you can call it that. And we realized very early on that viewing point cloud data, moving point cloud data, manipulating it and editing it was very difficult. So we decided to set up Veesus with a view to allowing people who are out there scanning for whatever purpose to view that data that they're actually scanning. Because even the software that was coming along with the scanners was struggling, given the number of captures and the large scale of the point cloud data that was being captured with those sensors. So we come up with the idea of creating a third-party aftermarket piece of software that allowed you to do that. So Veesus is 10 years old this year, and our first product was something that we called Arena 4D. So inside this product, there was a very powerful engine, and there still is, which allowed you to view pretty much unlimited points in a sort of on a standard type PC, without any special hardware or really high-powered graphics card and CPU, etc. So Arena 4D was our first piece of software, and that's been selling very well over the last 9 years, and it is effectively very mature and going from strength to strength. It's now turned into far more than just a point cloud viewer. It's a CAD viewer as well, if you wanted to put your Rhino models inside it next to your point cloud data to present to somebody, so that's quite handy. We then took the engine out of Arena 4D, extracted it, and put it into Rhino itself. So we could effectively give Rhino the power of our engine, but with the familiar native environment that Rhino users are completely familiar with. So if you had point cloud data and you use Rhino, plugin is the thing that helps you use that data for whatever you might be using it for. We then took that same engine and we integrated that with SolidWorks. The look and feel of the application within SolidWorks is exactly the same as within Rhino. It's just got a different front end, of course, because it's SolidWorks instead. So the engine's being used in all these three products. It's been extracted, so it's an SDK. We're looking to put it into many more in the future. And we're looking to put it into many more products where the company that owns the product is hopefully going to integrate that into their tools. So the format which we use for all of our point cloud data is something called VPC. It stands for Veesus Point Cloud. It's a format which has been very well constructed. It pretty much reduces the size of a LAS file or an E57 file by 70% on average, which allows us to stream that data very, very well. And it also allows us to view it very well within our engine. So the engine and the VPC format go hand in hand and they work very well together. So much so that we decided to create something else, which is what I'm calling Zapcha. Now, Zapcha is a combination of things. It is, in the instance of the image on the screen right now, an app which sits on the iPhone, which, if you have an iPhone 12, which Pro has a LiDAR built in, you could use Zapcha to capture with that device. So it has the engine on the phone, which then allows you to view that data on the phone, regardless of size. But if you were using the iPhone for a capture mechanism, you can then store that VPC file in the cloud. We have a cloud service called Zapcha Cloud Services. So from a capture point of view, you can store it in the cloud, it stays there. You can then access that via the cloud service directly into Rhino without downloading. You can stream it. That's the beauty of the VPC format, or into any of our other products straight from the cloud. We don't have to capture from the iPhone, of course, to share it in this way. It can be from any source. It could be photogrammetry, or it could be a LiDAR capture from a static tripod mounted capture, or an airborne or drone or what have you. It doesn't matter. We can convert it into VPC format, put it in the cloud, and you can share it between all of our products. And like I said, you can also view that in a number of different ways, including on mobile platforms using the Poetry network, which obviously is, as I say, obviously you may not know this, but it's a web browser-based viewer. But you can do that directly from Zapcha as well, because Poetry is integrated to VPC format too. So going forward, we are looking at taking our Extreme engine, which is the engine which powers all these things, as an SDK, and integrating it with other products. So this is our family. It's worth mentioning what we currently have before I dive into the actual demonstration itself, because that's what you're here to look at. But these things may be of interest to you. You may be a SolidWorks user as well as a Rhino user. You may like to try Arena 4D if you've made some models within Rhino that you want to then present, make an animation or what have you in Arena 4D. So it's worth knowing all this exists as an end-to-end workflow. Okay, I'm going to stop sharing my screen now, and I'm going to skip over to the actual demonstration itself. So I'll stop sharing now. Okay, so now I'm going to ask my colleague Matt to share his screen, which he is doing now. And he's going to open up Rhino. The plugin works on Rhino 5, 6, and 7. It doesn't really matter which version you have. And you're all completely familiar with what you're looking at now. You're looking at the Rhino screen. And if you look over to the right-hand side on the tabs, you can see a tab called Veesus. So this is where the plugin, once you've installed it, lives. Okay, so the first thing I'm going to do is click on the, Matt is, sorry. I'm going to click on the green plus symbol and going to scroll down to a VPC file and open up a building. In this case, this is from one of our customers. It's a church. And the reason I like to use this is because it's quite a large point cloud. for the size of the actual object it's scanned. And it's, if you look there, you can see it's 300 million points, and that loaded instantaneously. And you can freely move around inside the view without any issue whatsoever. Now, that could be 3 billion points. It wouldn't make any difference to the engine. You can view that natively inside Rhino. Okay, so once I click on the point cloud in the right-hand tab, you can then see some items below the point cloud, which are the settings which we provide with the plugin. The first one Matt is using is the quality. Now, this, if you can see the screen in the perspective view, is changing the quantity of points that are being loaded at any given time. This could be useful if you've got a legacy type laptop or piece of hardware that you're trying to view the point cloud data on, and it's just really low level, and it can't quite, graphics card can't quite handle the amount of points there. You can reduce the actual quantity of points being shown. You don't get any loading or saving as you're moving around. The points there all the time, but the quality helps if you are in an instance. There's very few people that use that now, because all the computers nowadays are easily up to spec. The next one down is point size. It speaks for itself. You can change the size of the points. If you're struggling to click on a particular point within this view, you can make it bigger. So you can highlight it and snap to it and click on it if you need to. Okay, so just take it down to a decent level, so 2. The next item down is render. So that has 3 options. One's intensity, which is in default. The next one's color, if you have color for your point cloud. And the other one is ramp, which allows you to colorize the point cloud intensity values in the RGB values you're seeing now. So to emphasize certain areas of the point cloud and make it clearer to see the different intensities returned by the scanner when it was scanning. Then we've got filling. So with that enabled, this is quite tricky to explain. However, what it does, it makes the points larger in size, depending on the ratio slider that's underneath the tick box. And it blends the points together in a sort of geodesic fashion, so that the points are effectively blending together to make the surface feel a bit more solid. So it's not just increasing the size of the points, it's making it more intelligent in terms of how those points are actually fused together. It's useful for trying to make a surface feel more solid when you're trying to reverse engineer it, for example, in this view here, and you're struggling to click on a point and see what its neighbors are doing. Okay, so if we leave that on. The next option down is opacity. The quality is right up, which is really good, but if we grab the opacity slider, we can drag that down to a very low level. And what you can see in all of these windows, so the top, front, perspective, and right, is the point cloud has been made almost transparent. So you can see the point cloud data within the structure without turning the points on the outside of the building off. So that's very handy for sort of seeing what's inside this particular structure. So you can basically drill down into the data as to what you want to see at any given point. Very powerful piece of functionality of that, and it's very difficult to do without our engine on the machine that you're using. So very powerful. Looks really good. Okay, thanks, Matt. The next ones are self-explanatory. One's brightness, one's contrast. But one thing I'll say at this point is that we've got one point cloud open at the moment. These settings for contrast, brightness, opacity, everything are specific to each point cloud that we open. So if we opened another one, that will have its own set of parameters associated with it, and you can effectively decide to switch between the two. You could have different settings for each. And if Matt's just opened up that one, I think it's a smaller cloud. Just need to identify it. I can see it on the right and the front. But if you turn off the church, you can then see the other point clouds there in its entirety. And what it looks like has happened here with this point cloud, which is really worth bringing out actually now we've got this, is that it's not sitting on the plane that you're working on. It's actually on a slant. So what we can do in here in the point cloud functions is click on the horizontal plane using a Rhino line. So Matt's just going to choose the horizontal plane here using a standard Rhino polyline. Okay, highlight it, and we're going to set a vertical plane. So we're going to zoom in here. And did you turn snapping on for this, Matt? Did you want snapping on? So turn snapping up. Yeah, snapping's already turned on. So it will snap to the points as we're doing this, which is really handy. And we're going to increase the size of the points as well, because we want to make sure we're clicking on a vertical point in this instance. Okay, so again, choosing a polyline function from the native Rhino toolset, and we're going to do a vertical line here and select it. And once we've got both of those polylines selected, we can then click on our alignment tool. Okay, that's it. Okay, and that one. Click on the alignment tool, and that has now aligned the point cloud to the plane. You can see it's upside down there, but we've got a feature which allows you to flip it 180, 90 degrees or what have you, to avoid you having to move the point cloud around freehand, or to avoid you having to move the plane to the point cloud. Very, very useful piece of functionality. Okay, so that was that. We can also use the origin button down the bottom of the it's on the bottom right hand side here. With a point cloud, you effectively get a bounding box around the cloud, which you can see by the XYZ coordinates that are in the bottom right hand corner there. That's the size of the bounding box, and that's the center of the bounding box. But you might want to redefine that. So what we can do, we can choose another single points function from the Rhino tool list, and click any point on the point cloud here, highlight it, and we can then redefine the origin of the point cloud. So that is now the center of the point cloud. So we zoom in and we can mouse over that. You can see the coordinates are getting near 0 on the XYZ there. Okay, and you can go and change the coordinates manually if you need, but this is quite a useful way of doing it graphically. Okay, right, so coming back down to the bottom of the point cloud functions for each of the point clouds, you've got a scale option. Now this could be if you've captured the data in meters and you've processed it in meters, but you're working in feet, you can go there and change the scaling for the point cloud itself. Okay, so that's quite useful. Some scanners also do scale the data that you've captured, and that's also easy to come in here and modify that scale in real time as you're using the data. Okay. All right, so we just turned off the pump again, and we're now back in looking at the church here. And we're now going to move out of here and look at slices. And our slice, if you're not familiar, is the ability to select a plane in your top view in this case, and create a kind of slice through the data, which can be viewed on the other 3 perspectives. So Matt's created a quick slice there in the top-down view, and you can see there are different lines on the front and the perspective and the right-hand views, which can be dragged up and down, which allow you to really piece through the point cloud data. So if you're reverse engineering this, for example, you could literally drag the slice down and sketch around each element of the point cloud as you were going. Okay, let's move my panel out of the way. Okay, with this slice, you can do a number of different things with it. You can change the color to make it more obvious. You can give it a name. You can change the width of the slice to make it more detailed. You may not want a 100mm width of line. You may want to make it even more detailed. So we've changed that to 0.2. So 0.05. So that's 50mm of a slice. So you can see the effect that has on the actual overall view through the point cloud. It makes it very easy to trace through that information. Okay, and also we have the step functionality, which rather than doing it freehand, dragging the slice up and down, you can use the step to literally step through a sequence of slices through the data, and you can see Matt doing that now. Okay, what else we got there on the slices that he's showing? Okay, we can do multiple slices if we need to. We can create what we call a vectorized slice. The first one Matt's done there is through a different plane. So you can see we're slicing through vertically and horizontally now. So you can highlight particular parts of your point cloud for you to get right in there to what you're trying to see. Okay, and when you select each, you can change the view you're looking at. Okay, so turn one off and select the other. Okay, did you want to do a curve now? Okay, so we're just going to use one of the polyline tools within Rhino again and create a curve on the point cloud. So you can see that it's in black just there, but we can select that. So you can see the curve, and we can then assign the alignment to curve function, which allows you to move through the point cloud on that curve itself. So if you drag it, you can see it going through the curve. Just see that going. It's following the path of the curve through the center line, and it's projecting the actual slice in that way. That's easier to see now from the perspective view. That's really good. Okay. Okay, what have we got down there now? We've got okay. Right. So the vector one. Okay, so we're just making a new slice down here, and with that slice now, you can see with it full screen, Matt's just clicked vector. So what that's done, so I was giving him a moment to set that up before I spoke over what he was doing. He sliced through the building there, and he's clicked the vector feature, and it's automatically created the vector around those lines within the point cloud. So if we turn the point cloud off, you can then see that is a native polyline that you can then use or may choose not to use, depending on what the quality would be. But in this instance, it looks quite good. There is also a feature in the vector which allows you to do the outline of the actual point cloud, as opposed to just the center line of the point clouds, which we can do now as well. So that's the outline. As you can see, it's drawn around the outline of the actual point cloud itself. Again, native Rhino polylines have been created in that instance. Okay, great. Okay, so let's get the views up again. Turn the slice off, and we're now going to go into clipping. Now, clipping is really handy for isolating certain areas of the point cloud, which you may want to get rid of. You may want to take a copy of to make multiple point clouds that you've got open inside your view. In this instance, we're just going to choose new clip, and we're going to select a part of this point cloud, and we're going to hide it. You can invert that selection as well, so you can hide everything else and keep what you've just selected. It's still there, it's just been hidden. Or if we turn it back on, we can also reverse the selection. We can take a copy of that if we want to. And that, what it does, that makes a brand new VPC file, which will then be listed in our Point Clouds tab in the Veesus plugin, which then comes with its own set of parameters which you can change, turn on, turn off as you see fit. Okay, it always takes longer than what you think it takes when you're talking over top of something doing a copy. Okay, that's done that. So now what you've got in the point cloud, you've got the fusy new point cloud, which Matt's just turned off, and you've now also got the pump house, and you've also got the wing of the building, which has just been created. So very useful for separating out your point cloud if it wasn't already separated by means of the fact it's been captured using multiple scan locations. But yeah, very useful and very quick. You could delete that data if you wanted to using our clip-in feature. And you like I say, you can recover all this information. It's non-destructive, so you can delete that. Okay, so that's gone. Okay, so restore the point cloud back to its normal, its form of beauty. So select the right one, that's it, and it's come back. So even though you have deleted it from your view, it hasn't actually deleted the original file, and because that could be quite annoying if you had done that. Okay, next thing we're going to go to is viewpoints. Viewpoints are quite handy, I find, if you're trying to present some data. So if you're inside this particular scan, you can create a viewpoint, and it basically it saves the location that you're currently at, and you can call it a name. So if you move somewhere else in the point cloud, double click the viewpoint, you end up back where you started. I use it for presentations normally, which is really quite good if you're to save you muddling through a point cloud trying to show your boss or your client or even a group of people what you're looking at inside a point cloud. That's quite handy for that. Okay, so there's not much more to that than that. We have a shader which can be programmed. So if we just get a nice view of the point cloud here, you can turn the shader on, and that effectively applies a color ramp to the point cloud itself, and that's completely configurable. You can change the range of the colorization, so you can change the in this case, is that 1 meter? Yeah, that's 1 meter. So you can see the color has changed within that 1 meter from red to green, and you can repeat that up the building if you wanted to by clicking the repeats shader option. Numerous uses that could be used to give you a quick understanding of how tall the building is without measuring it. You could look at that and say, yeah, that's 5 meters plus 5 meters or what have you. Or you could, if you wanted to, look at the interior of this building, and by applying a color shader to it, you can determine different heights in the floor. So if we claim that's the floor itself, you can see by the shading change that that particular part of the floor that we're looking at there in red is lower than the green. It's a very basic example of that, but if we could change the figures associated with the ramp or the shader, you can see in more detail the gradient that the point cloud's coming down. Okay, it could be useful on roofs, could be useful on roads, all sorts of things. Okay, I'm just literally showing you the functionality within the plugin itself. I always find a new use case for the use of this all the time. So anything that I say is not necessarily always the way it's going to be used by the people who do actually use it for their jobs. Okay, so we can probably turn the shader off. Okay, what else have we got? We've got the clash detection, which is quite handy actually. For this, it will require Matt to draw a cuboid within the window that we're looking at now. So we're going to clip off the side of the building and hide that. We're going to look inside the building. Now we've noticed that we can draw the cube from the Rhino tool palette, but the second we turn on the shader, the share screen option in Zoom has a tendency to flicker the screen. So it doesn't happen when you're using it in real life because Zoom's not always on, but you can see the little bit of flickering on the ground there. The shader has effectively caused that probably a graphics card clash to do that when used in conjunction with Zoom screen share. So what Matt's done, he's made a cube and he's basically put it up against the point cloud and clicked clash detect. And what you can see are the red crosses. If we can zoom in a bit on that map, you can see the red crosses are the points at which the point cloud data clashes with that rectangle. Which is handy if you're trying to determine a particular type of vehicle, for example, that's going to go through a new piece of equipment on a production line. You can see where a clash might happen. We can also then convert those X's, those red X's, into a polyline, a point. Okay. Yeah, so that's that looks good. So you can look at those independently within Rhino without the point cloud being on. Yeah, there they are, all in white. That's the polylines or the points. Yeah, like I said, the flickering is because of the screen share. Okay, so I'm going through this in quite fast steps because I'm trying to get as much out of this as I possibly can to show you guys exactly what the functionality is within Rhino. But we've got here also lined up is the Zapcha interface with Rhino. And like I said at the start, the Zapcha product itself basically has a capture mechanism, i.e. the app on the phone. And in this instance, we have the tab, which is accessing the cloud storage, so our cloud services. Matt's just basically logged into his Zapcha account. You can see all the point clouds, the VPC files that are on the server. And we can double click on one of these. Now, I think this was actually captured with the iPhone. Okay, there we go. That's because you have the church open still. So we've had this before. So while that's loading up again, you can access there's a tab for the Zapcha content on all of our products, and once you see the data open, I'll get Matt to unshare his screen and I'll show you the rest of the presentation. Okay, so let's try that again. Okay, right, so there's the point cloud. It's streaming, so it took a little while, but not an obscene length of time. Now, this is a capture of our office corridor taken with the iPhone, and it was basically walk down the entire length of the corridor in one single capture. We've adapted the app on the phone to allow you to capture up to 100 million points, and that's where we're at almost with this point cloud capture. So it's quite powerful for its first instance in terms of the point cloud functionality within the lidar on the phone, which is quite useful, and I can see it's only getting better. So Matt's just sliced through the point cloud there, so you can see our corridor. And just a quick outline. Okay, so that's what our corridors look like. Is it worth having a quick look inside the building with the point clouds on? Get to see what the point cloud capture actually looks like. Because what I'm thinking with this as a use case is someone's using a point cloud in the office. Somebody could be out in the field or in the building that is currently being reverse engineered, and a new piece of that is a piece of that building that needs capturing because it's not currently in the office being used, and someone's seen a hole in the data. You could basically use the iPhone and capture really quickly. You can see the quality is pretty good, but you could quite easily then share that to Zapcha, and the person back in the office could be using that point cloud data straight away without any file conversion, just a complete end-to-end workflow for a really, really cost-effective handheld device. Okay. In terms of the Rhino plugin itself, that's kind of all we had to show. There's a lot there to take in. I kind of went through it quite fast. I'm quite conscious of the time we have. But I will get Matt to stop sharing the screen now, and I'll come back to my screen. You stopped.
Do you want to share your screen, Mark?
Yeah, yes, please, yeah.
I think then first Matt needs to stop sharing the screen. Now you should be able to share yours.
Thank you very much. Cheers. That's okay. Okay, so that was running through the actual software itself, all live. So thank you, Matt, for helping out with that. But I always revert back to people who actually use this for a living and actually get in there and know how to use the point cloud for creating an output for something. And what we have on our website are a number of use cases, not just for the Rhino plugin, but other products that we have as well. Just so you can see how some of the users of the data are actually, benefiting from the application itself. So these are the four I've currently got. Thank you so much to all of you guys. If you're online, I don't know who's online. If you're for helping with these customer stories. These can be accessed from our website by clicking on the customer stories link, and you can see here there are a number of use cases. But in relation to Rhino, we have the CAD room. So Craig Reeves, thank you for that. Amiga Geomatics, that was Brett Duffield, and we have Studio DiMarchi, that was Massimo, who helps with this one. And Court Engineering, that was Arnold Court, who helped with this one as well. So there's 4 use cases for using point clouds for Rhino that are well worth a read if any of you have been enticed by seeing the functionality on your screens. Okay, so they're there to be looked at and used. So that's my presentation. And also, if you can see my screen still, this is the Zapcha website. So if you are a user of ours currently or looking to be, this is the simplicity of the current site, where you can literally log in and you can view your point clouds that are on the server, and you can access these quite simply by clicking on any of these. Just click on this one. VPC files, and this then uses the Poetry network to view the actual data from the Zapcha cloud services. So this point cloud itself, this is 1.5 billion points of data.
Sorry, Mark, we see only a blank screen.
Oh, really?
A
Okay.
white screen.
Okay, stop my share and reshare. When did that happen, Carlos? Was it
at the end, the last half minute?
Right.
After your last slide.
Okay.
Now.
How's that?
Yeah, perfect.
Right. So you've missed the bit where I've showed the Zapcha web browser, but I just logged in effectively. It gave a list of the point clouds that are in the Zapcha cloud, and I've literally just chosen this one for no particular reason, just that it's very big. You can see the data streaming in here, but this is in a web browser. This is in Chrome, and yeah, this is 1.5 billion points of point cloud data. So you could quite easily stream this into Rhino if you wanted to, or into any of our other products. So you can see the benefits of using the VPC format, and you can see the benefits to using the Zapcha Cloud if you wanted to work collaboratively. We've got numbers of customers who are working in different locations in the world or country, and they've been asking for a long time for mobile visualization. Zapcha gives you that, and the Zapcha Cloud gives you the collaboration activity that you can enjoy. Okay, so I'll stop sharing there and just check to make sure I've got another presentation slide, which I haven't. It's just questions.
Yes, excellent. Are you so? Did you finish already, or do you want to show anything else?
1 second.
Again, we see only a blank screen.
Yeah, I think.
Now, no.
Okay, yeah, that's it. It's questions now, if we have any questions.
Okay, perfect. So many thanks. It's amazing, and I think we learn a lot because, well, at least me, I had a rough idea, but now I know that there are many options in point clouds for Rhino that I didn't know. Yes, there are a few questions. Actually, the first one is if you support RPC format.
Inside Rhino, you mean?
Yeah, or well, from what I understood, you need a VPC creator. I mean, you need VPC files, right, in order to import them into point clouds for Rhino. Yes. And with VPC creator, you can generate those files, but starting from Leica or XYZ, etc. And there is one of the viewers, Hoda Ganji, that asks if you plan to support RPC files as well, RPC format.
Okay, give me 1 second. Are we doing RPC format still? Yeah, okay, yeah. The reason I ask is because we had a whole number of different file formats, including FLS, the Faro format, we had Regal formats in there, we had dot product formats, we had all sorts of formats in there to allow you to convert all those types. But the integration of the file formats actually came with some problems because if they changed the file format, it would mean we'd need to change our VPC creator. So what we've done, we've essentially narrowed it down to the main file types like LAS and the 57, PDS, XYZ, that kind of thing.
I guess there are in the market some converters, right, from RPC or RSCS to XYZ or Leica or whatever.
Yeah,
Thank you.
Right.
What else? Well, people are, of course, saying it was great. Thanking you for the presentation. And okay, one person asked, why are you using Rhino 6 and not Rhino 7? I told him already that it does work on Rhino 7, but
no
maybe it's
reason.
okay, as it's your own display pipeline, so I guess there is not a difference between Rhino 6 and 7, right?
Yeah,
because in Rhino 7 the display pipeline has also been improved.
Yeah, if you download the plugin, it'll work with all of the Rhino 5, 6, and 7.
Perfect. What else? Yeah. Fadri Jacqueline asks, what's actually the difference between VPC server and Zapcha?
Good question. The server was originally designed to allow somebody within their own company to set the server up on a dedicated PC store all their VPC files on that server and share it in their local area network. So within a company network, they're not having to share point cloud data on hard disks and USBs and all those good things. So it was in a standard location, which is configured, backed up, it's secure, all those things. Because we have a good number of customers who will not use Zapcha Cloud because they're kind of police users or they're security services, that kind of thing. So, but Zapcha is different to the effect that it doesn't actually use the point server to actually serve the data. It streams it down using a different mechanism. So point server is for inside your company. Zapcha is for people who want to share it across the world.
Perfect. One more question. This one from Jill Jones. I'm looking to scan curtain interior parts of a car and then model the area needed to create a surface for other purposes. Is this possible with your product using an iPhone?
It is. The iPhone capture itself, the accuracy of it is possibly not quite as high as it will be in the future variants of the LiDAR on the iPhone. So I would possibly use it on the air of with an air of caution in relation to the accuracy of it. But you could do that, absolutely.
So it's also, but of course, it's an iPhone. It's not a professional 3D scanner. I mean, it has now this feature, but it's...
That's right, but I can see in the future, this is only going to get better from a mobile phone.
Yeah, like photo cameras in the end. We only use the ones in our mobile devices at the end, well, most of the times. Yeah, and in the same, Martin Kornieczny says, which phone application was used to photograph the office?
Zapcha.
Yeah. That's the one.
Yeah.
Well, your application.
Yeah.
You can find more about Zapcha on Veesus website as well.
Yeah, that's right.
Okay. Yeah, very interesting. Do you offer a free trial at all of Point Clouds for Rhino or Zapcha?
Yeah, Point Clouds for Rhino, we do a 14-day free trial, so you can download it and you can use it. We have a VPC creator. If you need to convert your point clouds, that's free anyway. You can download it anytime you like. Zapcha is a free app anyway. And if you were signing up to the cloud services, that is free for the first 1 GB of data that you're storing. So if you wanted to give it a go, you can effectively try the end-to-end workflow from mobile phone through to Zapcha through to Point Clouds for Rhino for free.
Perfect. What else? This new question from Camlin Mutley. Is there a way to quickly generate surfaces from the point cloud data? For example, to generate to the middle plane surfaces from the walls and slabs of a building?
Could you go through it again?
Yeah, if there is a way to quickly generate surfaces directly from the point cloud data.
Oh, no.
I guess this is more automatic reverse engineering.
Yeah, no, it's not. No, the automatic
because it's millions of points, right?
Yeah, I mean, it's something we have looked at in the past, but I have found that a lot of people who have used it can be really good on some really clean point cloud data. It can be really bad on some not so clean point cloud data.
Exactly.
And I find that people have always checked it afterwards anyway.
Yeah. Well, he asks, I guess he knows about the complexity of freeform shapes, but for planar surfaces or slabs, that's the question.
Yeah, no, we haven't got anything like that.
Info on trials and pricing. Well, if you visit the Veesus website, you will find, or food4Rhino, you will find the trial. And as for the pricing, I guess it's also on your website.
It certainly is, yep.
Okay, just visit food4Rhino or Veesus website. What else? Coding Husky asks, second in Camlin, is there a surface interpolation triangulation ability in the plugin?
No.
That's the same question. No, that's not automatic. So it doesn't detect any features. It's not mechanical design, reverse engineering software.
Yeah, exactly. It's not, I mean, it's something that we could potentially look at in the future, but we just haven't done it yet. We have investigated it, we just haven't implemented it yet.
And then Rodrigo Chavez asks if I guess about Zapcha, if it's only available for iPhone. It's
currently, yes. The capture only works with iPhone 12 or iPad 12 Pro. You can view point cloud data on any iPhone from iPhone 8 upwards. So you could stream a point cloud to your phone, to the app.
Okay.
But other platforms such as Android-based phones, that's next. That's what we're doing next. Yeah.
Nice. And the last question here, is it available for Rhino for Mac?
No.
No. Why not?
Well, yeah, what was quite interesting is we were supporting Mac for probably 5 years, and we probably sold 2 licenses to Mac users, which sounds really strange, doesn't it? We had, I mean, I use a Mac myself. Many users of Macs worldwide, but it doesn't seem to be that many using Macs, Rhino, and point cloud data. So no, that we kind of pulled the plug because it was causing a huge sort of parallel development effort each time.
Understand. What else? Oh yeah, that's interesting. Is it possible to access the Veesus Point Cloud through Grasshopper? So do you have any Grasshopper extension to the plugin or in the works?
We do. We have, I think, some scripts which allow it allows it to interface with Grasshopper. I can't go into too much detail about that because I can't talk to it that greatly, but it's something that we've helped people out with before. Yeah, definitely.
And right now there are no more questions, but we have with us my colleague Vanessa Steck and Bob McNeel. I don't know if they want to say anything or if they have any comments or questions.
Okay.
Vanessa was very interested in this in this webinar as well, because we all do technical support and we get the question many times. Is there anything for Rhino to handle large scan data?
Yes, absolutely. It's a mix. And that's a little bit why I wanted to come see what the functionality was all about. So since Rhino 7 came out in particular, we've had a lot of demands for managing point clouds in Rhino, and also reverse engineering them. And what's interesting is that has always been the case for Rhino, but mostly for product. And lately it's been in the AEC world that we were getting requests for. So often it's just for visualization purposes and like a graphical support surrounding a scene or whatever. And other times it's also for reverse engineering. So I wanted to know, how it worked with Veesus and so forth. And I did want to add something about the Mac version, not that this should change your mind, but there is a possibility. I mean, you probably started doing the porting it to Mac a long time ago. And I wonder if that hasn't changed. Maybe it's still not probably, a good investment. I'm not sure, but there are more and more requests on the Mac side as well. I just thought it.
Okay, yeah, I wouldn't discount it completely. I mean, supply and demand. If we do get information that it's required, we will reignite that fire. So we've had it all working on Mac before. So
I think today maybe 15-20% of our customers use a Mac.
Okay.
With students, it's higher. The number is higher.
Yeah.
With students, and depending on the regions. I mean, I think that students in the US use more Macs than students in Europe, for example. Yeah. I don't know about Asia, but yeah. There is one more question. Where do I find a fastener Liberty? I think he wants to say, where do I find a fastener library, but I'm not sure. Fastener.
Fastener?
Yeah.
As in button, do you mean? I don't.
I'm not sure. If Benjamin could reformulate his question, that would be very helpful because we don't understand it, sorry. Otherwise, also on the Veesus website, you can find their tech support email. So any questions you might have in the future, feel free to contact Mark on his email. And there are no more questions. So is there any major upgrade do you plan in the next months, years, etc.?
The plugin itself?
Yeah.
We have a roadmap.
Mm-hmm.
And what we tend to do, we react very fast to customer requirements effectively. I mean, in the past, we've been guilty of putting some functionality in just because we think it sounds like a good thing to have.
Mm-hmm.
It turns out that no one's ever going to use it.
Mm-hmm.
So we tend to listen to what the customers actually want, and we modify the software all of the time based on those requests. If even if one or two people ask for a particular functionality, it goes in. So in terms of what's coming up, who knows? There could be something for surfaces. Who knows? I don't know. It really comes down to what we get asked for.
Perfect.
Asked a lot actually, but
so you follow our philosophy. We always try to.
We do, yeah. It's sometimes fraught with a waste of effort putting things in that you think are going to be nice to have. When you're not an architect, or you're not doing reverse engineering on buildings, you're just kind of selling the idea.
Okay, there are no more questions. So I think it was a great webinar. We learned a lot. We all now want to give it another try, or a new try if we didn't do that yet. And again, many thanks. Hope we can repeat this webinar when you have some news, a new version. And for you viewers, thanks again. As mentioned before, this webinar is being recorded, so it will be available on this same link right after it finishes, in case you miss, for example, the beginning. And next week, there will be a new webinar, in that case, about Nautilus nautical design. So if you are in the marine design field or naval architecture, don't miss it. Thanks, everyone. Have a nice day, a nice evening, and stay healthy.
Thank you.
Bye-bye.